All right, so the knowledge check for this week, knowledge check 8. First question just asked if the probability density function below was valid. So if we were talking about a discrete probability distribution, we'd be adding everything up, making sure it's summed to 1. If we're talking about the function, we're looking for the area under the curve being 1. And since this is a triangle, we're just doing 1/2 base times height. So that is 1/2 times our base, which is 2, times our height, which is 1, which gives us an area of 1. So that is a legitimate probability distribution. The next question says, let's find the probability that x is greater than 1.5. So in that case, we are looking for, I want to draw on it, from here and over. So we're trying to find the area of this little tiny triangle, which again is 1/2 base times height. So 1/2 is, we got 0.5. And then the base of this thing is also 0.5, right? We're going from 1.5 to 2, which is a 0.5. And then the height, well, also 0.5. Boom. So that is our probability, 0.125 or 12.5%. You could have also done this based on the proportion of this curve. You could have divided it up into little tiny triangles. You would have seen that there's 8 of those same triangles. So this is 1/8 of the entire area under the curve. Okay. Question 3 was something I cared about a lot, and I emphasized in my lecture, this idea that the probability of any particular outcome, even the mean, is 0. Right? This is why we don't care about if there's a greater than or equal to or just a greater than here. They're both giving us the exact same value when we're talking about continuous, whereas for discrete, we'd have a difference. All right, question 4. Looks like I've already done some of these. The distribution of the heights of adult men is approximately normal, with a mean of 69 and a standard deviation of 2. And then he has a z-score of negative 0.5. So I do like this type of question because this is a question where typically we would just revert to calculator shortcuts like normal CDF or inverse norm. But this question requires that you understand what a z-score means. So this is a very likely type of question for the exam as a multiple choice. So this is all about that idea that our z-score gives us how many bunny hops below, in this case, average we are. So we could also think about this as the little formula, right? Bloop, bloop. That formula, x is equal to z times sigma plus mu. We could think about our drawing. We said this was 69. And then we went out 2 in every direction. And this guy was half a bunny hop away. So his value was at 68. So this is really trying to get us back to this value, this idea that like, okay, we do know more than we normally let on to, right? So there we go. That's all the stuff that we know. So he is 68 inches tall. Oh, but that also means he's shorter than 69 and he's half, all of those things are true. So again, getting us to this idea of what the heck a z-score is telling us. The standard normal being centered at 0, 1. And the probability of getting a z-score less than 1.4. Lots of options here in terms of finding this probability. One option would be to draw your curve. Z-scores are centered at 0. We want 1.4 and less than. So we could use normal CDF because we're looking for an area under the curve. Negative E99 because we're looking at the left side and we're going off forever this way to infinity. Up to 1.4 and then a mean of 0 and a standard deviation of 1. Or this is exactly what the table gives. So all you'd have to do is look at the table for 1.40 and you'd be done. Either one is completely legit. I personally would use the table because it's quicker to find this value. And then the last one here is just having you match these beautiful curves to these different possibilities because I really want us to get around this, second to last one, the idea of how these curves fit. So in 3 of them, we are looking for the area under the curve. In the last one, we've been given it. So this one is our C because that's the only one where we're given a percentage. And then the other ones, we got a between, which is really hard to see because there's not a good drawing here. So we'd actually have to think about, okay, the mean is 266 and looks like we're between 2 values that are less than 266. Oh, this is the only one where we can kind of see that cutoff. It's barely there. We can see it cuts off twice. Before 250, well, 250 is less than 266, so our cutoff will be somewhere. What? Did I screw this up somehow? Percent, at least 290. That's good. Feel good about A. My brain is working slowly. What percent gives birth before 250? That's off. That can't be B. Huh. You guys are now watching me make a mistake. What the hell? I will have to re-edit those. How did I screw this up? Right? Because I'm just sitting there going, okay, mean of 266 is right here. So 290 is above. So there's no, these are two that are above. 250 is below. Both of these are below. So we should have had two values that were below average, and I have a mistake here. So I will go in and edit this particular problem and give people points back, which sucks because I have to do that manually. But I'm not happy about that. All right. Okay. Question 8 is an inverse norm question, right? We have our normally distributed and we're given a percentage. And then another one with z-scores. So basically here, we have to use this idea of this sweet formula to find the score out for Bob, who we have the z-score for. And this one used to have an error in it too. Did I fix it? This is a good question because it used to have an error, and I hope to God I actually fixed it. So let's see. Lucas is in the 98th percentile. Bob is in 1.75. So let me do this math to make sure I don't have another error. All right, so 1.74 times the standard deviation, which is supposedly 150 from up here, plus the mean of 1200. So this is going to be Bob's score. So Bob scored a 1461. So that's the only one that's right. I think I used to have the wording wrong in terms of if he scored lower or higher. So I'm just going to verify that Lucas's score is higher than that with distribution, inverse norms. This would have been question 8. We're looking at the 98th percentile, which is already a left side probability with a mean of 1200 and a standard deviation of 150. Please, 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 please be more than 1461 since I have that error on the other one. Yes. All right, so question 9 is good. I don't know how I screwed up question 7 and have never fixed that, but I will go in and give people points. So anyways, that's knowledge check 8. I'm sorry if I confused you with question 7. Or maybe I'm just being insane right now and it's actually right. If I am, feel free to shoot me an email and tell me I'm being an idiot now. Or I think probably past me was stupid. Who knows? But those are the 2 knowledge checks. I'll go through the Kahoots as well. So if you wanted to get a breakdown of how those went down, you can have those also.